So what was this? This is 4, right? And this was negative 5. And this was 1. And this was, and this was. I'm going to do this except for 2 of you. All right, so here's what's up. All right, you go to where x is negative 3, right? What y value are you going to put there? Negative 2, yes. Okay, so where x is negative 3, you're going to put a y value of negative 2 on there, right? Now, is it going to be a hollow or filled in circle? It's going to be a hollow. Very good. Okay, so that's what you see up here on the graph. There it is. Okay? Now, look, x is less than negative 3. So for every x value that is less than negative 3, you're going to assign a y value of what? Try again. Negative 2. I'm going to assign a y value of negative 2. Is right. Okay? So here we go. I'm going to go after that. Here's that, right? And does that stop or does it go on forever? It goes on forever. So I'm going to put a 0 on the end of it. Right there. There you go. That's the first piece of the puzzle. That's your top piece, right? Okay, let's go to your middle piece. I'm going to go where x is how much? Where x is what? Now, I go to negative 3 first. Go to where it's negative 3, and go give that a y value of 1. Is that going to be hollow or filled in there? Filled in. That's what you're going to see now. There we go. There it is, filled in. Okay? And negative 3, 1. Now I'm going to go where x is equal to 2 and give it a y value of 1. Is that going to be hollow or filled in? It's going to be a hollow. Very good. Let's go do that now. There's that piece. Now what are you going to do between those two things? Okay, draw a line, right? Draw a segment there. There's a segment. Now you got the middle piece of the puzzle. The middle piece of the piecewise. Okay? Okay, now let's go to the last part of the piecewise. Now you're going to go where x is equal to 2 and go and put y is equal to 3. And is that going to be hollow or filled in? Filled in. Very good. You're right. There's a fill in. There it is right there. Now you're going to go take all the values of x that are greater than 2, right? And always assign them a value of all the values of x where it's greater than 2, and give them a y value of 3, right? And then is that going to keep going on forever? Yes, it is. There we go for that part. All right? That's what that should look like for the piecewise, okay? Okay, so this is known as a step function, right? So when do you use a step function? Well, there is this thing called a greatest integer function. So let's do this. Here's one of these. It looks like this, okay? Okay, now let me explain to you what they're asking you to do. Look, tell me this. Let's change my color here, okay? Okay, I'm going to give you a number. Let's put 2.3 there. Okay, what is the, okay, least greatest integer? The least greatest integer when I say the number 2.3. So what integer is less than 2.3, but it's the greatest of the least integers? What would you say? 2 is right. The answer comes out to be 2. You're right. That's the least greatest integer, okay, for 2.3. Let's try another one. Let's try another one. And these are easy to pick up on. You just understand how it works. Okay? How about I try 3.1? What's the least greatest integer? 3 is right. The answer would be 3. Very good. You understand. Let's try another one. Let's try another one. I'm going to give you this one. Negative 4.1. What's the least greatest integer for negative 4.1? Negative 5. Whoever said that, you're right. It's negative 5. Okay? Okay? Now, if you're getting confused, I don't understand what's happening. Look, here's the thing. Think about number line, right? Here's 0. Here's negative 4. Here's negative 4.1. Here's negative 5. Now look, here's where I am, right here, right? Negative 4.1. What integer is less than that, but it's the greatest of the least? And it's negative 5 is the answer, right? So the answer comes out to be negative 5. Okay? All right, so that's that kind of greatest, okay, integer functions. There's another kind. There's this kind. It looks like this now. Okay? So now we have a ceiling on it, right? So if I give you a number like 2.7, I want to know what is the greatest integer that is the least of the greatest. The least of the greatest, right? For this. So what would the answer be? 3. Beautiful. The answer is 3. Now you're understanding how it works. It's 3. These are really simple to do once you understand it. Well, that's 3. Let's try another one. How about this one? 1.99. What would it be? 2. Very good. The answer would be 2. Good. You guys are getting this. Okay, let's try one more. Okay, let's try this one. How about negative 3.7? What would it be? No, not negative 2. Negative 3. Okay, the least greatest. Okay, negative 3 is bigger than negative 3.7, right? Okay, but it's the least of the greatest, right? So it'd be negative 3 is right. There you go. That's how you do these, okay? Okay, so look at this. I've got x is negative 3. Okay, if x is negative 3, which one's going to go into? The top one or the bottom one? The top one. Okay, if x is negative 3, how much would y be? Positive 3. You got it. Okay, if it's x is negative 2, which one? Top or bottom? Top. What would it equal? 2. Okay, if x is negative 1, which one? Top or bottom? Top. What would it equal? 1. If x is 0, which one would it go to? Top or bottom? Bottom. How much would it equal? 0. If x is 1, top or bottom? Bottom. How much would it equal? 1. If x is 2, top or bottom? Bottom. How much? 2. If x is 3, how much? Bottom. Bottom 3. Right? There you go. Easy. Okay, everybody understand? Now we're going to put these points on the graph. Okay, so you're going to go to negative 3, 3. Put that point on the graph. Negative 2, 2. Put that point on the graph. Negative 1, 1. Put that point on the graph. Okay, 0, 0. Put that point on the graph. Okay, 1, 1. Put that point on the graph. 2, 2. Put that point on the graph. 3, 3. Put that point on the graph, right? Okay, let me ask you something. Once you put all those points on the graph, what does that look like? It looks like a V. Here's what you're learning. When you graph an absolute value equation, it always looks like a V. It's always a V. Okay, we understand? Okay, so now take out Mr. Straight Edge and let's draw our lines. Let's connect it together. There we go. Here it is. Arrow. Here it is. Arrow. Right? Okay, then together. Then I'm going to start. All right, so now this is an absolute value equation, right? So in other words, the equation would look like this: y equals the absolute value of x. Makes sense? All right, now let's go to the next question. So you've done number 6. Let's go to number 7a. What is the domain of that function? This is what you guys worked on last week. What's the domain of that function? Okay, now say again. Negative infinity to positive infinity. Curvy, curvy. Beautiful. Negative infinity, positive infinity. Curvy, curvy is exactly right. Okay, however, first period when they did this, they wrote it the other way, the inequality way, right? So they wrote it this way. Okay, negative infinity, okay, x is greater than negative infinity, less than positive infinity. That's just as good, right? Hey, let me ask you this. What if I asked you to write it set notation? How would you write it? Set notation. X is the set of, okay. Yeah, but how do we learn to say this? The way you guys told me. How do you say that? XCR, right? Okay, and XCR, right? Okay, so be X such that bar, right? XCR, right? Remember the little curly Q? Looky there. Hot dog. You guys are ready to do this. So when we get to a test. Okay, let's go on. Okay, so that's the domain, right? Let's talk about the range. What's the range of that thing? 0 and 0 infinity Yeah, straight curvy, right? 0 infinity straight curvy, right? Okay, or the way they did it first period, okay, because they would use an equality notation, okay? Y is greater than or equal to 0, less than infinity, right? Okay, both right ways. What you're saying and this way is both the same. Okay, just different ways of doing it. Okay, so that's how you do it with inequality notation. Let me ask you this: what's the set notation one? Y such that, okay, I mean 0 is greater than or equal to y. Okay, right? Y is greater. I'm sorry. Y is greater than or equal to 0 is what I meant to say. Yeah. So such that y is greater than or equal to 0 is right. Good. You got that. Okay. So all good. Okay. All right. So let's do that. Okay. So here's the point we're advancing on. This is the vertex, right? Okay. So we're good there. And let me ask you this: does this thing have a minimum or a maximum? A minimum or a maximum? A minimum, right? Okay. Minimum. The minimum is 0, 0, right? All right. That's on the next question. Let me ask you this: does it have an x-intercept? Does it have an x-intercept? Yes. What is it? It's 0. Does it have a y-intercept? Yes. What is it? 0. Look at that. You're answering all these questions. Okay, let's go to D. Does it have a line of symmetry? Yes. Okay. What's the line of symmetry? It's the y-axis. What equation is the y-axis? X equals 0. Very good. The y-axis, which is the equation, x equals 0. Look at that. That's answer D. So you got all these knocked out. Okay, so let me ask you this then. Okay, we're going on to number 8 now. So use the piecewise definition of the absolute value function to evaluate each expression. So f of negative 14, what would you write down? F of negative 14, how much is that? 14. Good. 14. F of 8, how much is that? 8. F of 0, how much is that? 0. Now here's the tough one. F of 2 minus square root of 5. F of 2 minus square root of 5. What would you write down? It would be, let's see, okay, so if it's negative square root of 5, it would become positive square root of 5. And then in this case, if it's 2, it's going to become negative 2. So the answer is it's negative 2 plus square root of 5. That one's kind of tough. Negative 2 plus square root of 5, okay? All right, so now we're to number 9. Could you have determined the values of this function in item 8 another way? You just did it another way. You just said, oh my gosh, it's absolute value. It's how far it is from 0. In other words, if it's positive, it's positive. If it's negative, it becomes positive, right? You guys did it.